My company objective, we set up a new company called Telet Research in Northern Ireland about 2 years ago. I escaped from my previous employment at Truephone. Many of you will know me as the person who built the back end of the Truephone network. But we managed to escape from that about 2 years ago, and I took the innovation and research and development teams with me and set up a new outfit based in Northern Ireland. And our objective is to build all the bits and pieces that you need to set up a privately owned 4G network, 4G or even 5G network. And we started this, launched it at TADSummit about 4 years ago, first started talking about it. Everybody in the room thought it was a brilliant idea, apart from the two gentlemen from Ericsson who were sitting in the front row, who thought it was a very bad idea. And ultimately, we're looking to find all the bits and pieces that you need, all the missing pieces, to set up a private LTE network and make it really easy to deploy. So that's how we started it off. 2014, we built the first demo in conjunction with our friends from Canonical, Ubuntu, Telestacks and Metaswitch, built a network, and amazingly, it worked. 2015, we made it big, and we had a whole load of application developers then join in and put stuff on top of the network. And whilst we were doing that, we wanted to prove that it was scalable, so we had a load generator running in the background, gradually ramping up traffic in order to force it to spawn new processes and rescale, refactor. The objective was to get up to, was it 100,000 concurrent calls or something rubbish like that? We got up to 86,000 by the end of the demo. Not quite 100,000, but I think it proved the point. And at the end of that demo, the AWS bill for running it was something like $2.65 or something like that. Good value. 2015, we then, what do we do then? No, 2016, we ran on it using Line Micro software-defined radios and a whole load of other stuff as well. And we saw the appearance of a detector of a masked terrorist who was actually Dean Bubley wearing a ski mask, which was... It was originally supposed to be me, and then you got someone else to do it. Oh, was it really? Yes. Well, it failed anyway, didn't it? And then last year, 2017, we added proper radios, so proper IP67 rated acceleran radios, and subsequent to that, we deployed them. So let's move on quickly. God, I'm waffling. I need to go faster. Yeah, that's what we did in 2017. All of that, with all of those components. It didn't work perfectly either. A bit of a crash and burn. So, where are we now? Yeah, that's what we built. So we had some acceleran radios on the front end with embedded EPC running back through an aggregator, which then worked into our back-end core. That wasn't live at the time, but today it is. Let me explain a little bit about organizations now. Telet Research is the organization, my company, who set up mobile networks. MONeH is the technology that we use to do multi-operator neutral host operations, and also providing the multi-IMSI, multi-crypto SIM cards, more of that later. And Chalke Mobile is an organization that we set up, a community interest company based in southwest England, southwest of Salisbury, and everybody knows where Salisbury is now after the Russians got nerve agented there. So Chalke Mobile is the bit that owns all the radios. Quick word about how to build a mobile network the conventional way. This is the way you do it. You do all of that. And it costs you about 6 million? No, bit more than that, considerably more. And this is kind of what it looks like. I stole these slides from my friend Keith Milner, who has lots of experience in building mobile networks. And that's what a conventional mobile network looks like. expensive. But we don't do it that way. We do it the modern way, which uses purpose computing platforms and, these. I actually changed all those names so that they were correctly spelt. But you can build a mobile network now for about that much, about $500,000. Yeah, and that's what a complete mobile core looks like today. Incidentally, for you, Adam, that is now located in the Broad Chalk BT Exchange. Yeah. Who was it? Somebody showed that slide. Yeah, stole my slide. Yes, you did. But what you didn't do was do this. This is cool. Showing how to make that very scary diagram considerably less scary. And this is what you do. You actually use Gamma Elio. I take it everybody knows what Gamma Elio is here. Does anybody not know what Gamma Elio is? Yeah. Well, if you don't, it's the most brilliant lump of open source. Started off life as a SIP router, but of course, as time has gone on, it's grown other bits, including diameter. So it effectively is an IMS core in itself. And so you can build a complete mobile core out of Gamma Elio. And in fact, was it 2 years ago, Alan, we had Daniel Miele, who's responsible for the project, actually built a complete mobile core on an Ubuntu handset. So he was running a mobile network from a mobile handset. How cool is that? In fact, it wasn't cool, it's quite hot, because I think he was trying to melt it. Okay, one of the other bits and pieces which we all know you need is Spectrum. You can't run a mobile network without Spectrum. This is where Adam smiles to himself. But the good news is that Spectrum is becoming a lot easier than it was. I put up a slide very similar to this last year, and this is where all the cameras came out. They started going click, 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 click. I've updated it very slightly. All of these lumps of Spectrum are more or less available in different places. The really exciting ones, I think, are probably, if you're an American, the 3.4 gigahertz bands, which are available as license shared access throughout the state. So anybody who wants that spectrum can use it. Also extremely exciting for lots of people is the license-free stuff, band 46, in the 5 gigahertz band. And interestingly, the new iPhones that came out a couple of weeks ago support band 46, which is interesting, isn't it? Yes, they do. So, okay, let's talk about identity and authentication, because this is another really tricky bit to do. SIM cards. If you want to set up your own mobile network, you will need some SIM cards from somewhere. And it's pretty tricky getting them if you're not a big mobile network operator, because normally you have to order them like 10,000 at a time, and they are difficult to set up. So the good news is that we can help with that. Oh, and just to prove that we've got a little bit of background, this was the launch of the new iPhones a couple of weeks ago, and you'll note who the #1 eSIM partner is. It's a funny little outfit called TruePhone. And between you and me, we built all the technology for that 3.5 years ago. It's taken that long to get into the iPhone. It was supposed to be in the iPhone 10, but never quite made it. But it's in the iPhone 10R now. TruePhone offers multi-IMSI, multi-identity eSIM profiles that you can select dynamically. And we built that 3.5 years ago. So that's just me being super big-headed, I suppose. But anyway, further some development. Last year, I actually crashed and burned, coming back down to Earth with a thud, crashed and burned with my dangerous demo in that I managed to screw up some of the parameters in my black SIM card, the bottom one. The good news is we fixed all of those. We're now onto blue SIM cards, and they work perfectly. So if you want a multi-IMSI SIM card with multi-crypto, then we have them. We're going to make those available shortly. Let's very quickly talk about 5G now. Lots of people get really confused about what 5G is all about. And most people think, oh, 5G is a bit like 4G, it just goes a bit faster. Well, it's not really the case. This is where I'm watching Dean smiling. I like to use my left hand for...
Just another G.
Yeah, it's just another G, yeah. But as far as I'm concerned, it's all about trading off between three different axes. And you can't really have all of them at the same time unless you pay a huge amount of money. So one axis is speed. So we all know that 5G goes fast, very fast if you want. But the other two axes are just as important. One is latency. So if you're driving a car or flying a drone or doing anything in real time, you want super low latency. And there's a cost associated with that. Similarly, if you're doing things with IoT type devices, you might want a device that lives in a building in a cupboard underneath the stairs, and you have to get out into the network. So you need super radio path capability to do that. Or you might have a device with a battery in, and the battery needs to last for 10 years because it's embedded in your fuel tank, and changing the battery is a real pain. So that's another axis, power, which is the same as range. How much power can you consume? And 5G is all about being able to trade off between those three axes. And they all work against each other. It's difficult, I'm not saying it's impossible, but it's difficult to have all three at the same time. So normally you'll be somewhere, you'll either have one or another, or a mixture. Which is interesting because when we come to bill for it, the conventional billing mechanisms don't really fit particularly well because conventional billing for mobile is all about traffic, bits and bytes and SMS messages and things like that. So how do you bill for latency and for power levels? It's slightly trickier, isn't it? Well, we think we've got kind of solutions for that, which we're practicing and demonstrating in the Chalke Valley on our little private network. So we've got a number of different revenue streams. The first one is the conventional kind of roaming revenues, but we're not doing it the GSMA way. We're using a little trick that we learned when we bought a mobile network in Montana. Now, in North America, there are still a few micro networks lurking around, and for them, it's not cost effective to do the full GSMA AA19, AA14 roaming settlement. I mean, it's just a load of rubbish. It's just too complicated, so they don't. They run a scheme called mutual forgiveness. And the way that works is instead of accounting for every little bit of traffic, you just account for the totals between the different networks. And as long as the traffic balance is roughly in balance, so within a ratio of 3:1 normally, you don't raise any invoices. That's great because if you're a tiny little operator, it costs money to raise invoices. So, hey, let's not do it. But your next question is, what happens if you go outside of that 3:1 ratio? Well, the answer is there's a mechanism there to do a recentering payment, which then sets everything back to 0, and off you go again. And that is considerably simpler than trying to account for every single SMS and, 10K of data, which is brain damage. And the other advantage, of course, if you don't raise an invoice, then you don't get taxed on it either, which is a bit of a bonus. So that's what we're doing. We're looking to establish mutual forgiveness roaming arrangements with each one of the big UK mobile network operators, and we'll extend that internationally. So the second revenue stream comes from domestic comms packages, and shut your ears, Adam, because we're taking on BT here. I sound like the chap from Romania, don't I? We're going to fight. No, we're not going to fight anybody. We're nice, friendly people. Actually, I've learned that fighting mobile network operators and big operators really is not a good thing to do, because they might be big, slow old dinosaurs, but they can still hurt you. Am I out of time already? Cool, crikey, I'm. Okay. So what we're doing there is we're offering flat rate broadband with 2 phone lines, unlimited phone calls, subject to an acceptable use policy, all for a flat rate. All of that done deliberately so we don't have to run a billing engine. We don't like billing engines. They're expensive, complicated. We're not going to do it. So it's all flat rate everything. And then the third and the biggest revenue stream comes from running network slices for other customers. An example of that in the Chalke Valley might be the emergency services network, so police, fire, and ambulance, for whom deploying a radio access network in the Chalke Valley would be incredibly expensive. So you, for a 20th of the price, we'll just offer them a network slice, and they just use that, if that kind of makes sense. But there are other network slice customers like the National Health Service. I'm completely out of time. But anyway. And I just very quickly want to show you some Chalke mobile pictures just to prove that it's real. That's the coverage area of the Chalke Valley. It's about 16 miles by about 4.5, 5 miles. That's where we deployed the first cells. Oh, bit of video. Let's show a bit of video. I'm going to go over time. I don't care, but I'll cut it short because there's one bit where Minty, quickly. We're very proud of this video. So this is actually that's my chimney. Really I live in a 450-year-old house, Americans, and my house is older than your country, and that's my mate Jonathan. Have we got any audio? Because I want to get the bit where the minister says nice things about us. So that's my chimney with a cell on. You will notice it's not just a cell. There's also another point-to-multipoint linking equipment in there. Keep going, Jonathan. That's the guy who puts all the TV antennas on the roofs in the Chalke Valley. It's not, and definitely not Andy. No, he'd fall off. Yeah, you can see the cell on the left, the point-to-multipoint on the right, and the bit in the middle is the GPS for timing.
What solutions can we hang on the end to make your business better?
And it says ComCon,
to help you do more of what you already do, but also to think about on farms, for example.
Bit more.
Different business activities.
We want the minister to say nice things about me, and that's a phone with no coverage.
John Glenn is our local MP, but also government minister.
There he is.
He's been a huge supporter of the project since the outset. He's believed in our ability to both come up with a solution, but he's also believed in the principle that oftentimes it's local solutions that are needed for local issues. And there have been many false starts in solving the mobile broadband hotspots. And frankly, without John's support, I don't think we could have managed it.
Well, as a local MP, I'm always keen to get behind projects and enthusiastic individuals who want to change the community they live in for the better.
James and John.
And James and Jonathan have been fantastic.
Fantastic, yes, we like
driving
that.
This
okay, we can cut that now. So can we just very quickly go back to the other one, because I just want to show a couple more photographs just to show it's really real. This is not made up. Come on. So in question, how do you get the backhaul? Adam asked this. Well, the answer is it's BT fibre. That is a really professional BT fibre job, that, isn't it? Super stuff, BT. But then runs into a cell like that, which that one's on Rook Hay Farm. And again, we've got another point-to-multipoint. And the antenna, 4G antenna, is actually that tiny little sector antenna there, which works quite well. And then, at the other end of that point-to-multipoint, you have something that looks a bit like that, with the dish pointing at the point-to-multipoint, so you don't have to fibre up every single cell. We're running about 500 megabits per second across that link. And then we've got, at the bottom of that big tube thing is the little software-defined radio, which incidentally, we are running both 2G and 4G waveforms at the same time on that. Whoa! And then the big lump on top is the antenna. And here's proof that it actually works. So that's me walking the dog about 2.5 miles away. I am on top of a hill, but you can see it's a short mobile LTE. Not a huge amount of signal strength, but it doesn't have to be because we're in the country and there's no noise. Okay.
Excellent. Well done, James.
I'll stop there.
So a round of applause.
Whoa. You only gave me 20 minutes, didn't you?
Exactly, but you made it real.
It's all real. Come
demonstrating for several years now. It's all real and running on a lot of the platforms that you've been building on, mainly open source.
Mainly open source, yeah, and not costing a fortune.
Which is an excellent job. So well done, James.
Thank you.
So we need to move on now. So Peter, if you can come on down. So I have to thank Peter for doing such a good job in filling in. So you'll need to give your laptop to Inti. He'll get it connected up and get you the flicker.
Well, whilst we're doing that, can we have a question?
Okay. I know. There you go.
We like questions.
So do you give your Chalke Valley mobile customers their own SIM cards, or do they roam in with someone else's?
No, we don't. And that's done deliberately, because if we gave them a SIM card, we would have to then run a billing engine. Yes. Oh, behave yourself. Not this week. And so the way we deal with that is if you've got a mobile phone, you just have to roam in using another operator's SIM. It's one of the ways that we remain friendly with the mobile network operators, because we don't want to fight them. Because, in the past I've done that, and there are still people in EE's legal department who know my name, and it's not good. So it's better to be friendly with them, really.
So again, James, thank you so much.